Let's say Peer 3000 with pallet movement solution. We are building these robots that can move pallets across the shop floor. But that's not enough. What we also need to do is that can we provide user the data that how many pallets are there at dock 1 today or right now, how many pallets are there in 2 hours, or how many pallets were actually moved, even though you can't see that. Work in progress might be different, something might be loaded in the truck, but you have the real world analytics, right? So the whole idea is that the robot today is automating a physical action. But as it's becoming more and more part of the operations, it will be able to provide insights on the operations and even assist on the operations.
Hi, wherever you're joining me, I hope you're doing well. Welcome to India Tech Report, a platform dedicated to chronicling and supporting the growth of India's deep tech and climate tech ecosystems with the occasional segue into other areas of tech entrepreneurship. I'm Hari Arkli, and this is my In Conversation podcast. In today's episode, Rishabh Agarwal, co founder and CEO at PeerRobotics, gives us a sense of how automation is changing for small and mid sized manufacturers and outlines his vision for collaborative robots. With a background in manufacturing and technical training from IIT Delhi and University of Maryland, Agarwal built PeerRobotics with the aim of simplifying human robot interaction and making automation intuitive for even non technical users. The 6-year old company's systems are designed for practical deployment in diverse industrial settings where robots learn routes through human demonstration and adapt to existing workflows. In this conversation, Agarwal also describes how Peer Robotics approaches product development, aiming to own the whole stack. The company takes advantage of doing much of its engineering and development at its centers in India, while also tapping advanced R&D experience in the US in certain areas like computer vision. Thank you for reaching out and very excited to do a good update on Peer Robotics. So maybe we can start with a very quick intro to what Peer Robotics is today. Give us a sort of overview of what the company is about today, what you're focusing on, and we'll go from there.
Awesome. No, thank you, Ari. So, as a very high level, Peer Robotics is a collaborative mobile robotics company. And essentially, the whole idea why we started the company and where we are today is to make robots simple so that people on the shop floor can integrate, deploy, and use them. So that's kind of like the core concept that we have seen mobile robots. There are several kind of platforms out there, but almost every time, whenever customers would have to adopt those technologies, they would have to change their operations or they would have to change their assets. Like they might even change their trolleys or pallets that they are using, and then also a massive time and effort on training their team members, or on the other side massive engineering effort from our side to make sure it works at their facility. And Peer Robotics goal is to remove that by building robots that can first of all adapt to existing assets that customers have, and then also enabling technology that it is more intuitive for people on the floor how they are used to working with other humans.
Hmm. So again, for the layperson, I mean, I tend to include myself in that category as well, even though I love to talk to folks like you. Explain what you mean by collaborative robot in the first place.
So the collaborative robot is a broader term of robots that can work next to humans, work along with humans, and also potentially learn from humans. So the whole idea is that not all collaborative robots learn from humans, but that's where kind of we are going slowly, where we are trying to build these platforms where even the interaction between these humans and robots can lead to teaching for the robots. So one very good example is actually Tesla self-driving, right? Full self-driving. If you think about it, your car is manual, user is driving it, but then on the back end, Tesla collects the data on how the person is driving it. So slowly, when they roll out the full self-driving, if the car does something wrong and a human intervenes, it is actually teaching the car. what did they do wrong and how the car should do better or that self-driving should do better, right? So similar concept that how you can teach different algorithms with human in the loop is how can you teach robots by bringing human in the loop.
Hmm. Okay. From our earlier conversations, your context is the industrial setting, factories, warehouses, and so on. So, in that context, what is the significance of this collaborativeness, if I may put it that way?
Yeah. So it really depends on the customer profile. So let's go a little bit deeper on even in manufacturing or warehousing, who's our customer? So most of the time, the companies that we are serving at Peer Robotics are the industries who have not been able to adopt robots because A, either their operations are too dynamic, like they change every 6 months, every 4 months, so they are not being able to justify the cost of fixed automation, or B, they are really a small scale, or even if not small scale, their team is designed in such a way that they don't have any robotics engineer or even like an engineer dedicated to make these automations kind of in their shop floors. So that is the ideal customer profile that we work along with, because for them the biggest barrier is that they really need a technology that is simple so that their existing staff can work on it, plus also adapts with their changing requirements. So we are not making anything rigid depending on, so that tomorrow if their operation changes the robot doesn't work. So that's kind of like we are going towards.
Hmm. Just to follow on this, give us a couple of quick examples of customers that you're allowed to talk about and how they're using your robots.
Yeah, so imagine like without disclosing exactly the customers, but imagine small, medium scale suppliers, right? So imagine suppliers for an automotive industry. They might be making a very specific thing, crankshaft or any specific component that you can pick up. Now the thing is, they typically serve two, three different industries and companies together, and whenever the production line or the variant changes, they have to change their operations accordingly, right? And mostly they are also operating at a kind of like production forecast of 6 months or 1 year max. So it's not like they can invest for that specific company's production forecast for 3 years down the line, right? And that's like a good example of the company that we work along with. There are a lot of other companies as well. You can imagine a general manufacturing, like you might know the water coolers or something where you store something. So some customers around those lines, even small equipments like cleaning equipments and all, customers along those lines. So general manufacturing which have high variance kind of going along, and then the dynamicity is there.
Hmm. Okay. Can you now give us a sense of some of your specific products? Tell us about your sort of flagship line.
Yeah. So we have actually recently launched our Peer 3000 platform, which is a 3,000 pound payload capacity system. And it's heavily inspired by kind of how human does operations. So the same robot can automate the movement of trolleys, pallets, or even tug a train of trolleys. So if you look into the manufacturing industry or the manipulator industry in general, manipulators are the typical robots that you see most of the time, six-axis robots. The benefit of those robots is that they always had this concept of end effector, right? So no matter what the customer was doing, typically you would have an end effector which is custom or personalized to that customer, so they don't have to change on their operations. But if you look into mobile robotic space, robots that are designed to move material across shop floors, across warehouses, they would always come in and make changes on their existing trolleys of customers. So let's say they would say, hey, to go underneath them, I need this much clearance, or to grab or a hook to a trolley, I would need this particular attachment at that point, right? And that always created additional barriers, because now the customer is no longer just bringing in a robot to automate their operations. They are changing their operations and assets so that the robot can work with them, right? And that's the reason why adoption has been very lacking in small medium scale industries, because it's not just the cost of robot, it's actually the cost of those custom operations or customizations that require to make the robot work. So Peer 3000 removes that problem. It is designed in such a way that it can grab any existing trolley like a person does, literally like a handle. It can grab a trolley by the handle, Or we can create custom attachments on Peer 3000 that can accommodate to existing customer assets. So rather than changing, let's say, hundreds of trolleys, we adapt the existing robot, one, two, three robot, to adapt to those 100 or 200 trolleys, right? So that's a much more cost efficient and faster approach for deployment. But the robot can also do American pallets, ground to ground, which is a big use case in the US. And then it can also do other kind of systems like tug a train of trolley. So even not just a single trolley, it can move a complete train of trolleys.
Hmm. And did you say that you've also combined lifting in the same robot, lifting, moving, everything?
Yeah, so we lift the pallets from the ground. We can have different attachments. The platform itself is designed in such a way that really it's an end effector ecosystem. We are rolling out with three solutions today. Like three solutions are trolley grasping solution, which grabs literally grabs a trolley like a person and moves it in that controlled fashion. Imagine like a I don't want to use the word humanoid, but think of it like a big humanoid that can move 3,000 pound trolley. So heavy trolley movement solution there. And then pallet jack kind of thing. So the robot is actually like a pallet jack, moving American, European pallets ground to ground, lifting them and then moving them ground to ground, and a tugger attachment. But we definitely see a world where we would have way more solutions that are coming out of the same platform. So Peer 3000 has given us the kind of layer of platform, and then now we are slowly rolling out different solutions on top of it.
Hmm. And can you, again, from a layperson's point of view, can you give us a sense of the autonomy of each robot? How autonomous is it?
Yeah. So the platform itself is completely autonomous. We have taken a very different approach than any existing systems where we took up all the cameras. Like we have six cameras in this robot. We mounted four of them at 2 meter height. So they give a complete field of view from floor to like ceiling 360. And then on top of it, we added more cameras on the bottom to detect and track, kind of like follow a human or understand the assets which are nearby so it can dock with an accuracy, coupled with a safety rated 2D LiDAR. So we can also ensure industry grade safety when it comes to operations in factory floors and warehouses. Along with all this sensor suite, the robot can also understand human feedback. And from human feedback, I mean literally you grabbing the robot and it acting like a, let's say, battery operated pallet jack. But in this case, as you are moving it, the robot is learning from your feedback. So imagine you want to do an operation and you know exactly how you want the robot to do that operation. Rather than programming it, you show that. So you walk on that operation with the robot, and next time onwards, it can do that fully autonomously. And that has been kind of enabling people on the floor to teach the robot rather than program the robot.
Hmm. So I'm assuming this is more sort of a bona fide AMR and not really an AGV kind of robot.
Correct. Fully autonomous. We don't change anything on the infrastructure and brought in the learning from human as well. So we are not leaving it open ended that, hey, now the robot would do anything they want and then bring it smaller. We actually want humans to tell the robot what it's supposed to do.
Hmm. So the Peer 3000, will this be sort of the platform on which in the foreseeable future you're going to build your variants and products and so on? This is your main robot now.
Correct. We have this is the main platform. We have other platforms as well, which are more compact for use cases in a congested production line. Peer 3000 is a little bit bigger system for 3,000 pounds. We have other systems for lighter weight, like 1,000 pounds and 500 pounds. But yes, in the foreseeable future, we are seeing all of them to continue and Peer 3000 to roll out more solutions.
Hmm. And under the hood, I mean, can we dive in a maybe sort of next level of detail and get a sense of what are some of the innovations that have gone into this?
Absolutely. The main thing is the entire platform is like developed in such a way that the processing is happening on the edge. What I mean by that is we are not streaming any data out of the robot. We are not kind of collecting any data that is sent to cloud constantly, or none of the decisions are made that are reliant on the IT per se. So everything is happening on the robot, and we have trained our own custom model to ensure that we can run on edge. So it's not that we have picked up a generic VLM and kind of like running it on top of the robot. We have actually distilled the model in such a way that we only focus on areas of interest for peer. So let's say if we are moving pallets, The robot is just going to worry about pallet detection to such a high accuracy that it doesn't really care about if other object is exactly that trolley or not. It just needs to know that that's an object I have to avoid. But pallet becomes a region of interest. So the platform can then focus that, okay, this is a very important asset for me because I have to pick it up. So I could be very accurate when I go and pick it up. And that has been a game changer because we're able to build different models, run it on the edge, and choose wisely as we do different operation, which model to run.
So, since you have a presence in India as well, can you talk about what you do in India and what are you doing in the US, and if you have other centers, that as well.
Absolutely. So I think India is still our main manufacturing and R&D hub. So we are doing most complete manufacturing in India today. We are slowly bringing assembly in the US. So we have recently opened our second office in US in Detroit. We have our first office in Connecticut. That's kind of like our headquarters, global headquarters. And then we are slowly bringing our assembly operations, our support team, and then our vision R&D in the US in Detroit. So our vision side of R&D focus and developing some of these models is sitting out of US, whereas our product design, product manufacturing, and then base level R&D or navigation, path planning, that's sitting out of India.
Hmm. So the vision tech that you've chosen to center around US, I'm thinking that part of the reason might be that in terms of the deep science collaborations and partnerships needed, you are looking to be closer to where that expertise is available. So, can you delve into that in the sense that where are we in India when it comes to sort of the broader development of that kind of an ecosystem of serious science based expertise feeding into industries like yours?
Hmm. That's a very good question. And I think, Hari, the biggest thing that we see as a challenge for peer is not whether there is a market or not, or whether we can build these robots or not. It's about talent. Can we hire people at right time to scale, right? And that has been the biggest bottleneck through and through, like finding right people at right time to scale. And the core reason is, I think, in difference between US and India in that talent side, that we definitely see a lot more hands-on or with past experience engineers in US which have worked on different startups or different problem statements and delivered something around this vision or training custom model side of world. In India, there are phenomenal engineers, but they're limited. So finding them who have hands-on experience takes a little bit longer. And we are still a startup. It's still a small company, and we have to be mindful how we bring new team members on board. So we are more focused on all the engineers that we have are experienced engineers who have worked on it and who have built on these systems before as well. We do hire kind of like entry level engineers as well, but then the training process and all is something that we are still not there yet. So we are trying to build kind of our own muscle in that area of bringing a strong pipeline and training them. But US versus India, what we have seen, especially when it comes to custom model training or vision models, there is a much more or much bigger talent pool in the US with hands on experience. In India, this talent pool is still a little bit early. There are exceptional engineers who are actually probably coming from US back to India to build this talent pool, but they're also then very looked after. So finding them and converting them as a team member is also a big challenge.
Hmm. Briefly, I'm curious about your experience and your viewpoint on how the pipeline is looking in terms of the fresh engineering graduates coming out of our engineering schools.
I think specialization is missing. That's my sense whenever kind of we interact with someone who is recently graduating, and I don't mean in a way that kind of you have to invest 10, 15 years in that specialization. I mean that even during the undergrad period or even during that initial college period, what has been the focus of their own work. What we have typically seen is people kind of like doing multiple projects and scratching the surface, not going too much in depth of it. So that's one area that I believe universities, and I know IIT Delhi is doing phenomenal work in this area, trying to build these schools of specialization and other universities would also be investing in that. So we are really looking forward to these new initiatives. But I think the main focus should be to create a kind of world where we are specialist, because I think general knowledge now a lot of these AI models can provide. The area where these AI models might not be able to kind of provide value would be that in-depth specialization and understanding what might fail, because we have done hands-on work here, right? You don't have to go to a kind of like a different company to work on this area, even if it's like a project like your pet project, but going in depth, going to a level where you do build it for reliability, you do build it for, let's say, constant usage. I think that's going to be a major game changer if the universities start pushing it for the students.
Hmm. Okay. Just a brief data point. I mean, how many folks are you at now at Peer Robotics?
25. Everyone is an engineer.
Hmm. Yeah, I mean, I would imagine at this point it would still be very engineering and R&D heavy, and maybe in the coming quarters and years you'll be looking at more the quote unquote go to market kind of folks.
I think that's also an approach that we have realized that in this area specifically, because we are working along with customers and we are solving their problem, rather than sales, it's more like a solutions. So even our go-to-market strategy is not by hiring salespeople, but it's hiring solutions engineers, because they are the more aligned people, because their goal is also not to sell the robot, but to make sure that we are solving the problem of the customer. It's a little bit different. Let's see how it pans out. But even in the foreseeable kind of like next couple of years, our focus point or our emphasis would be building a stronger engineering team.
Hmm. To the extent that you're comfortable, give us a sense of how you're doing as a business.
Yeah. So we doubled our revenue for last 2 years constantly. We have now more than 25 robots in field, so actively deployed and mostly in the US. So our focus area is also in the States. We have few deployments in Europe as well with some of the major automotive companies. But again, like the focus is in the US. So our goal is to expand in the small, medium scale manufacturing enterprise in the US rather than just targeting one or two big companies.
Hmm. Circling back to something that you mentioned earlier on, what are some of the biggest challenges in the way of adoption today, and what can you do and what's not in your control?
I think I think it's still those touch points. So if you think about from like the first principles, that why, if a solution adds value, you won't adopt. Either it's too expensive, so the value it adds doesn't justify the amount you would have to pay to get that value, or it's too complex. So the training process for you and your team members to adapt that to become part of the operations is too long, and usually it just fails in that process. Our sense and our belief is that it's the latter. It's not the cost of these robots that are the bottlenecks. It's in fact the adoption challenges. And adoption challenges is everything that we talked about, like how do we program these robots? If we change something on the production line, how the robots would react, because it's still a black box for a lot of people. So, and it's not about other companies alone. Like as we were doing business, as we had deployments, we also saw this. Like we saw that how customers, when they changed their operation, if something changed in the robot, they were like completely lost to it, because it's a black box for them, right? So they don't understand why the robot will behave X versus Y, and they don't have to be honest, because they are thinking from their first principles that hey, if I teach a human, that person adapts to it, right? Seems like the robot is just static in that time where it learned X thing when you went and deployed, and after that, it never learned anything else, right? So that's kind of like the major barrier to adoption. And I think for robotics in general, apart from, let's say, the form factor, we can go on form factor debate anytime, whether humanoid, wheels, arms, like we can discuss those things. But apart from the form factor, if something is gonna change the field of robotics, it's about learning, that how these robots learn add more value. Because if you imagine, like my family comes from small manufacturing, right? So they all are in the manufacturing space. That's how I went into this space. And when they hire a team member, right, for their operations, the team member might join to do something very basic today. But then with time, the team member adopts, learns new skills, and kind of adds value in other areas. Unless we see that in robots doing that, unless we see robots adding value in other area, that real scale might never open up.
Can you explain with an example?
Yeah. So let's imagine, let's take our own robot, like where we are going with it, right? So let's say Peer 3000 with pallet movement solution. We are building these robots that can move pallets across the shop floor. But that's not enough. What we also need to do is that can we provide user the data that how many pallets are there at dock 1 today or right now, how many pallets are there in 2 hours, or how many pallets were actually moved, even though you can't see that. Work in progress might be different, something might be loaded in the truck, but you have the real world analytics, right? And you can pass on that analytics, not just raw data, but process data and use it next time onwards, that you know your cycles, your adoptions would be happening more at 3 to 4 p.m, so how the robots would adapt, right? So these kind of like understanding how we can collect the data, analyze that data, and provide the value on top of it is very essential. So what we call this as an operations assistant. So the whole idea is that the robot today is automating a physical action, right? It's automating a physical action. But as it's becoming more and more part of the operations, it would be able to provide insights on the operations and even assist on the operations, not just on the actions, complete operations.
Hmm. If you extend this sort of line of thinking, in the coming years, uh, what you're doing today already, that will help you to sort of continue to differentiate from competitors or avoid the risk of sort of becoming a commodity product.
Absolutely. I think uh, the some of the recent works on generative AI, some of the recent works on training these models on low data, like not that high amount of data, but also using simulations or different augmenting tools to ensure we have enough data. I think that is going to open up this market. And with peer, especially kind of going in this area, bringing human in the loop, we are actually working along with humans as a team to figure out how can we assist them, how can we augment them, right? So we started the company with the philosophy is that designed to work with humans, right? We don't believe any kind of future where humans are completely taken away from the factory floor. I think their decision making is going to be very impactful. And what we want to do is build these robots that can add value today, X level, and then slowly kind of grow those value parameters as they're learning about the operations, as they're learning from humans.
Hmm. I mean, not to put you in the spot, but over the next year or 2 years, what would you be really happy with in terms of specific goals or targets, whether it's in tech development or in the on the market front that you can achieve?
I see tech as a method or as a approach, but I think if you ask about the goal that the entire team at Peer is striving for is to increase adoption among even small scale, medium scale manufacturing to a level never seen before. So the idea here is that even if a person is running a factory of 50 team members or 30 team members, our robots should still make a sense for them. If we are able to achieve that, that's when I would say the peer robotics would be successful. In other terms, if my dad would come back and say I can use these robots, that's kind of would be a good victory for the company because now we have opened up the market for customers who want to adopt, but they simply cannot today.
Hmm. I mean, in general, I mean, even beyond the world of areas like robotics, which are very, very demanding, even in things like regular software, SaaS products, etc., the so-called received wisdom is that if you break into larger accounts or enterprise customers, you'll probably become bigger or grow faster, etc. What is sort of the equivalent philosophy in robotics? And can you talk about that a bit more? Why you focused on SMEs? Why not look at bigger OEMs? Is it a question of competing against giants like MIR or I don't know, just thinking aloud.
Okay. So, so the thing is that the requirements for a large enterprise is very different than small enterprise. So let's take the thought process of Chat GPT versus any other big company, right? What Chat GPT or Claude or some of these systems did was not that kind of they brought in a solution just for small medium scale, but they created a horizontal platform which different industries can use, opening it up for even small scale industry, right? And we have seen that happening again and again, like history kind of rhymes kind of thing, right? So when you talk about SaaS products, all the big companies used to have their own server, have their own custom SaaS products, right? So all personalized at their own local area, right? CRMs were a big use case, and then Salesforce came in and they opened it up for small, medium scale enterprises. That doesn't mean that the large ones didn't take it, but their technology was in such a or was developed in such a way that it opened up the market for small and medium to adopt so that they can kind of get value from these systems, right? Same thing happened with AI models. Like ChatGPT did it for every industry. Previously, I would say I'm pretty confident all these like Flipkart, Amazon, everyone has their own custom model. They are already using their personalized model on their kind of assets, on their operations. They're already getting value from it. So that's not new, right? But horizontally creating a use case that enables other customers to adopt it, that opened up the market, right? The same thing we believe in robotics. Today, large enterprise, if you work with them, you would probably create a personalized solution, right? It's very much adaptable to their operation, fits their operation, and it's kind of just for them. But if you're able to build a technology that scales horizontally, the big ones would also adopt. It's not that they won't be able to adopt the technology, but you would open up a market that has not been touched before. And that's a much bigger market, and that's a much bigger problem per se.
Hmm. And for you over the next couple of years, I mean, I know that startups constantly need to be looking at funding, but in terms of any specifics, can you give us an update?
Our focus is still revenue generation. Like we are revenue generating company, we are growing our revenue, our costs are not that high, so this really allows us to grow as a company. We are very mindful of kind of how many team members we have. Everyone is again an expert in the area that they work on, but it's not like we have a massive team, right? So it's not something of a too high pressure for us, and our goal is that we want to kind of like emphasize on customers rather than focusing on fundraising.
Hmm. To ask you about how you look at peer robotics, for the next 5 year type of horizon. Do you foresee a line of business where software can be a source of revenue, or even where designed at peer robotics but built elsewhere kind of scenario, so on, or any kind of combinations, permutations where you could even license your tech and be more focused on software and design? And what is sort of the thinking going on in your head?
Yeah, we proud ourselves to be the entire product company. So so I think that's where we are very much inspired by Apple's philosophy, is that if you want to give users the best software experience, you build your own hardware. So the idea here is that decoupling these things are possible. Of course, possible. Companies have done it. They are very successful in doing it. But if you really want to solve something that has not been done before, I think it's very important to control the entire supply chain. Like vertical integration is very, very essential. To an extent that the entire design today is ours of the platform. The manufacturing data is generated by us. We have contract manufacturers that we work along with, but everything is controlled by us. So everything is coming down under the umbrella of peer robotics. So if for good or bad, everything is done by us, right? And this really allows us to control user experience, because there are companies who are big who get hardware from X, who get software from Y, and try to do the integration and then kind of like give out the entire solution to the customer. But we believe that if something changes, if their operation changes, if a new solution horizon comes, a new opportunity comes along, having that vertical control really gives us the speed, and we don't want to let go of that. So I don't see a foreseeable future where we will let go of that particular aspect. You asked another thing, which is like, did software generate revenue? It's already doing, right? So software is already generating revenue because we have different solutions that we provide to customers that are empowered by these platforms, right? Think of it as in very similar way again, since we've already talked about Apple, is that Apple has services business, Apple have the software business that is generating more revenue for them, right? As they rolled out the product, Apple Music came along, Apple TV came along, and different things came along. And that's our approach as well, that how can we add more and more value to our customers.
Hmm. So, I mean, in this context of sort of controlling the full stack, and since the Apple analogy is already out there, in your vision R&D, what is it that's really critical for you to control within Peer Robotics?
Yep, that's a very good question. The data and then the models. We control our models, like we essentially rely on the raw RGB data to train our models. And that is really giving us the edge, because tomorrow, if we have to figure out, or if a new system comes along that is much better than the previous camera modules, we can easily swap them out because the models are our own. So we are not relying on any third party models. It's not trained on any proprietary data. It's trained on the data that kind of we have collected, we have augmented, and we have trained in house.
Hmm. So, over the next, say, 2 years, what would you say are your top priorities?
It's always going to be making sure that we are making platforms simpler and more reliable. So someone also told me that it's very simple to do a robotics business. It's not that difficult. You just have to build the right product that adds value to customers. It's a simpler way of saying that. But yes, that's actually the reality, right? Like make it simple and then make it reliable.
Hmm. I probably should have asked this earlier on, but I mean, sort of question just popped up in my head. In your mind, or folks like you, I mean, experts like you in the industry, what would you say can be seen as an inflection point in the robotics industry, from which point you will see that adoption just sort of takes off? What is missing?
Yeah. I think the intelligence aspect in robots is definitely a big door opener. So there is still, I would say, an open space, which is how intelligent truly these robots are versus how programmed these robots are. Sometimes AMRs hide under the kind of like hard coded programming aspect by reflecting it as an intelligence, but that's not really true. That goes for us as well. Like it's not really there yet, but I think we are close. Now, I also don't think for robots we need general intelligence, but I think we need specific operational intelligence. And that's kind of is an easier thing to achieve. And that's what we are aiming towards. Like same thing is like self-driving cars. Now we have started seeing them rolling out to a good extent, right? It's not generally intelligent. Like it's not going to be generating images for you per se, but it's very specific to driving a car, right? And I think robots are going to be seeing that inflection point soon. A lot of companies are working in this area, including us. Like we are trying to build intelligence on these modules by kind of creating our own models. And I think that is going to be the biggest door opener.
That's it for today. You can find links to Peer Robotics' website and Rishabh's bio in the show notes, wherever you get your podcasts. For my pick of daily headlines on deep tech and climate tech from India and around the world, please listen to my India Tech Report Daily Morning Brief podcast. To support my work, please subscribe to my free newsletter, India Tech Report, if you'd like to get all these in one place. I'm Hari Arakli. Thank you for listening.